Hello everyone, welcome to OneClass YouTube channel. My name is Devansh Purohit, and today we are going to solve a couple of popular question and answer Q&As, and these Q&A are related to mathematics only. And a little bit background about myself, like I am a senior tutor at OneClass, and I'm currently in my final year of graduation. I'm doing my graduation in aerospace engineering, and that's pretty all. So if you need any help or if you need sessions, then you can check out the description links in the below. uh, then you can check the links in the description below, and so we will be moving. Yeah, so we'll be starting with first question is, yeah, so first question is, what is a square pyramid? Let's say this is a pyramid, this is another side. Yeah, so the top point, or this point, I'll just write it with a different color. This point is A. So A is the apex of the pyramid, of the pyramid. And pyramids are named after their base. Okay, thus a square pyramid is a pyramid with a square base and four triangular sides. It has five vertices, corner points, and eight edges. So let's see with this: one, two, three, four, five. Yeah, so it has five vertices, and it has eight edges. So one, two, three, 4, 5, 6, 7, and here we will be having one more, which will be 8. So we have 8 edges. Yeah, so pyramids are basically are of a lot of types, and as the pyramids are of a lot of types, we usually refer the pyramids with the base of it. So basically, if a pyramid has a square base, then we call the pyramid as a square pyramid or square base pyramid. Yeah, we call it as a square pyramid. There are other pyramids also, like there is one also. We also call pyramids with the help of their triangles or angles. So for example, one more pyramid is there, which is equilateral square pyramid, and one is right square pyramid. So these are further uh, subtypes of a square pyramid. So in an equilateral square pyramid, all the triangles are equilateral triangles. So basically, if I say, um, I'll just use blue again. A, B, C, D, then we'll have D, E. So in that case, for a equilateral, we square pyramid by A, B, C, triangle ABC, and triangle ACD, or and or and all other the interior angle of an equilateral triangle. Now a square pyramid can be considered a Johnson solid if all the triangular sides are equilateral, which makes all the edges of pyramids equal in the length. Yeah, so basically, if all the triangles are equilateral, then the sides will be equal. All the sides will be equal. is called an equilateral square pyramid. Another type of square pyramid is the right angle square pyramid, where all the lateral sides have the same length and the triangular sides are congruent isosceles triangles. Okay, so wait a minute, I will just set this to paper size. This should be A4 and portrait. Yeah, so for a right angle equilateral for a right where was that word, right square pyramid. Basically the pyramids, like, first I will make just a square. Now this, let's say this is the apex point of the pyramid. Then drawing is kind of horrible at this point. Yeah, so you can see the triangles are not equilateral triangles, they converge at a single point. So my ABC triangle and my triangle ACD and all other triangles are isosceles triangles. What is the spelling of isosceles? ISOSCELES triangles. And so what isosceles triangle means is that here AB will be equal to AC, and if AC is equal to AD, then basically all these sides which I'm marking with this color, this side, this side, this side, and this side will be equal. And isosceles triangle, so sides of the, or the edges of the triangle, the two edges of the triangle are equal. Now talking in terms of height, so the midpoint, and we join it with the sorry, if we draw one line from the apex point and we join it with the triangle, then we get the slant height. So let's say this point it as, let's say, small a, and this as small b. So in this case my a small b is height and my slant height is a small a. Okay, now here are the formula. This is the volume. So the volume is given in terms of base length, can be calculated with a square h over 3. Surface area, the surface area will be area of all the four triangles and plus area of the base. So surface area will be equal to a square. Then we have the lateral edge length. So the lateral edge length is basically the length of the triangle, this length. For an equilateral square pyramid, E will be equal to A. So here we have E equals to under root of h square plus a square over 2, and for height, the perpendicular distance from apex to the base will be equal to h square plus a square over 4. So the formulas are correct. So we'll write correct solution. Great job. Solution is correct. We'll go to the next question. Yeah, so what are antiderivatives? So antiderivatives are basically called integrals. So uh, like d by dx or partial derivative del by del x, it gives the slope of a curve. But uh, for graphical representation, let's say this is a slope. So d by dx at any point will give the slope of the curve. This is the slope. This is the slope. Let's say this is y, this is x. But when we go for antiderivative, for in the case of antiderivative, we basically calculate the area under the curve. So for antiderivative or integral, we calculate the area under the curve. And for a to b, in indefinite there is no limit. For definite, we'll have a limit of from suppose say a to b. So antiderivative is either integral, or usually we write it as an integral. So this is called integral or antiderivative. Like most people call it as integral in scientific community. No one, I haven't heard the term antiderivative from any of my professor or faculty. So these are some of the antiderivative or integral rules. First, we'll go with the 0 dx rule equals to c. We'll just verify it by just taking the derivative of c with respect to x. So if we get 0, then this rule is correct. So d by dx of c, and c is a constant, so yeah, derivative is 0, so the rule is correct. Then we go for one is identity rule. So integral of, basically this is 1 dx, which is equals to x plus so we take derivative of x plus c, and with respect to x, so derivative of x will use the yeah, so derivative of x is 1 and derivative of c is 0. So again we get this term, and we will go for the next one, constant multiple rule. Okay, so yeah, this is like if a constant is multiplied with a function of x and we are integrating that function of x, then we can take the constant outside of the integral, because this constant has no role to has no part in this whole integration. So we can take it outside of the integration and we can do the integration. Then we have there is some rule. So yeah, when we write in the differentiation, suppose if I differentiate f of x plus g of x, then I can write it as d dx of f of x plus d dx of g of x. In the same way, in integration, if we have a function of x plus a function of yeah, I can write f1, a function of another function of x, both of them are integrated with respect to x, so I can just separate. I can for indefinite I can just separate, but if it is for definite, then I will use the limits also. D dx plus integral of g of x dx. Again, we have some more identities. So yeah, one power rule also, we'll discuss one power rule. Okay, so we'll just discuss one more rule, which is power rule. So integration of x power n dx equals to x power n plus 1 over n plus 1 plus c. So yeah, in whenever we do indefinite integrals, we add a constant term always, because we don't know the actual function which will come after integration, and the function might have a constant, and when we differentiate it, then it might have happened that the constant has uh, converted to 0. But to avoid that problem, we just write a constant, and once we have the limits for the integration, we get the value of this constant. It can be 0 or it can be any finite number. So I'll just differentiate this with respect to x. So x power n plus 1 over n plus 1 plus c with respect to dx. So n plus 1 and x power n plus 1 minus 1, so it will be n over n plus 1, and differentiation of constant is 0, so I can cancel this term, and again this identity is also correct. So we'll go down. Differentiation and anti-differentiation are inverse operation to double check if the determined antiderivative is correct. Just differentiate. So we did that thing. So g of x, then g prime of x equals to f of x. Yeah, so we do the antiderivative, and this is the definite integral. We have the limits for this, and constant multiple rule. So dx of kx equals to k. Then we have product rule, exponential rule of differentiation, log rule, constant rule of integration. So 1 dx equals to x plus c. We just did this. Let me check all the formulas. So this is integration of, yes, this is sum rule, this is difference rule, and this will be x power n rule. E power x is just like that, and we have a power x dx k, so it will be a square over ln of a. This is also correct. I'll just cross check this once. So integral of a power x dx equals to a power x over ln of a plus c. So I'll just take the derivative of this term. So a power x for a power x, I need to basically do the log, take the log of this. So y equals to a power x over ln of a plus c, then ln of y will be equal to x, this will be ln of this whole term, a power x over ln of a plus c. So just for simplicity, I'll just take c as 0 for the calculation. So ln of y will be equal to this will be ln of a minus a power x minus ln of a. This is double time log of a, then I can take out the x ln of a minus ln of a and ln of y. Now I will differentiate this whole equation with respect to y. So this will be 1 over y, and dy by dx equals to x will be 1 into ln of a, product rule, and ln of a is 0. So the rule seems to be kind of incorrect. Yeah, no. The rule is correct, I think. Y is a power x over ln of a. So this will be multiplied by y. This was minus. So dy by dx equals to y was a power x over ln of a into ln of a. ln of a gets cancelled. Yeah. So this rule is also correct. In the same way, we can verify all the rules here. So let me just check the rest of them. So integration of sine x dx is negative of cosine of x. So basically the integration of cosine of x is negative of, so derivative of cosine of x is negative of sine x. So for integration we just write the negative sign for cosine. And okay, this is also correct. Tangent is secant square, so secant square is tangent. Cosecant is minus cotangent. Okay, secant x tangent x is secant x, and cosecant z cotangent z is okay. So all the rules are correct. Trigonometric angle sum identity. So yeah, we have some of the identities of sine x plus y. This is sum identity. This is difference identity. Then we have hyperbolic trigonometric functions. This solution is kind of very big. The given function 10 power x is a composite function with component functions 10 power x and x, which chain rule u, substituting u. Okay. Correct solution. Great job. Correct solution. So we'll move to the question number 3. Question number 3 is, what are sum and difference identities? The angles sum and difference identity are trigonometric identity derived by combining two right angle triangle to represent a larger angle. This angle is especially useful for breaking down uncommon angles to common angles whose trigonometric values we already know. And wait a minute. Yeah, so common angles whose trigonometric are listed. We have sine of alpha plus beta equals to sine of alpha cosine of beta plus sine of beta cosine of alpha. So I'll just verify, I'll just prove the first identity. So for proving, I will need one horizontal line. Different color line will be better. And I need this arc. Now I will draw a perpendicular. So this will be perpendicular, and this is my right angle triangle. And I will draw one perpendicular on this line, and I will draw just one line connecting for reference. and let's say this is O, this is A, this will be my B, this is C, and this is D, and this angle is alpha, this angle is beta, and let's say, so if this angle is alpha, I'll use a different color, green color, no, green. If I draw one perpendicular on this line, then as these two lines are parallel, so with the alternate interior angles identity, I can say if this angle is alpha, then this smaller angle is also alpha, and if this whole angle was 90 degree and this is alpha, so this will be 90 minus alpha, and if this is 90 minus alpha, this is again 90 degree, so 90 minus alpha plus 90, so the equals to 180, so this angle will also be alpha. Now let's find the sine of alpha plus beta. For sine of alpha plus beta, this whole triangle, the sine will be AB over OA. So sine will be opposite side over hypotenuse. This, then what I can do, I can write AB as AC. No, AC. I can write AB as, I'll just write this coordinate also as E, this one. So I can write AB as AE plus EB, AE plus EB over OA. Now I can separate this fraction also. So it will be AE over OA plus EB over OA. Now, which is equals to now for this one I will just multiply for AE, I will just multiply and divide with AC. So AC is basically this side, this one. This one is AC, so I'll just multiply and divide by AC over OA plus, for the other one EB, I should multiply OC, I think. I will be multiplying OC, or yeah, I will be multiplying OC over OA. Now, what is AE over AC? So let's see, AE over AC. So this is the base and this is the hypotenuse. So base over hypotenuse is cosine and the angle here is alpha. So it is cosine of alpha. Now AC over OA will be AC over OA. So this is opposite over hypotenuse. So this will be sine of beta. This will be sine of beta plus, now EB over OC, EB over OC. Now, okay, so I did one mistake. Now EB is equals to CD. EB is equal to CD. So I can write EB as CD. So we'll just erase this EB and we will write it as CD, because EB is equals to CD. Now CD, this is opposite over OC. This will be sine of alpha. Sine of alpha times OC over OA. Now OC is the base for beta and OA is the hypotenuse. So this will be cosine of beta. So this is the proof of the sine of alpha plus beta. In the same way we can prove the sine of alpha minus beta, and we can prove this cosine and cosine of alpha plus minus beta. So for in the case of cosine of alpha plus minus beta, we first have cosine terms. It is cosine of alpha, cosine of beta, then minus plus we have sine of, so I'll just write it in another page. So sine of alpha plus beta equals to sine of alpha cosine of beta plus sine of beta cosine of alpha sine of alpha minus beta equals to cosine of alpha cosine of beta minus, sorry, I was just sine of alpha cosine of beta minus sine of beta cosine of alpha. Then for cosine of alpha plus beta, we have first the cosine terms, cosine of alpha cosine of beta, then for plus we have one minus, and then sine terms, sine alpha sine beta. Then for cosine of alpha minus beta, we have cosine term first, then we get, for negative we have the positive sign, then the sine terms. Then for tangent of alpha plus beta, we have tangent of alpha plus tangent of beta. Now if we have a positive sign here, then we'll have a negative sign in the denominator. Same way, tangent of alpha minus beta will be equal to tangent of alpha minus tangent of beta over 1. So here we had negative, so we'll have a positive tangent of alpha tangent of beta. So correct solution, CORECT, correct solution. Great job. Solution is correct. This question was question number 3, I think. Yeah, so we'll have question number 4. What shapes are quadrilateral? So quadrilaterals are polygons, two-dimensional enclosed shapes that have four sides and vertices. Quadrilaterals include rectangles, square, rhombus, diamonds, trapezoids, parallelograms, and kites. So a quadrilateral has four sides and it is a four-sided polygon. There is no restriction for a quadrilateral to have say to have the opposite angles, or to have all the interior angles as 90°. We can have like any angle within it. It should be just the close figure of the so it should be just the it should be just a close figure with having four sides and four vertices. These are the four vertices and these are the four sides. Now a square is also a quadrilateral because a square, this doesn't look like a square. Yeah, so for a square we have four sides and it should be equal and parallel. For a rhombus we have, for a rhombus also we have four sides. Sides are equal. A, B, C, D. Sides are big. Solution. Okay, the solution is very big. I'll just wrap it up. Polynomial equations. So a polynomial equation is an equation that has multiple terms made up of numbers and variables. Polynomials can have different exponents. The degree of a polynomial is its highest exponent. The degree tells us how many roots can be found in a polynomial equation. For example, if the highest exponent is 3, then the equation has 3 roots. This is correct. And the roots of the polynomial equations are the values of x, where y equals to 0. So if we know the roots of the polynomial equation, we can use them to write the polynomial equation. Let's write a polynomial equation with roots 2, 3 and 1. So this is a polynomial equation: x minus 2, x minus 3 and x plus 1 equals to this. For an equation it should be equal to 0. So for the roots of this equation is it will be 2, it will be 3 and it will be negative of 1. So either this can be 0, that this term can be 0, either this term can be 0, or either this term can be 0 to satisfy this equality condition. And if this is an equation, so to get highest order, what I'm not going to solve, or like I have a kind of a good trick. So I'll just, what I do is that I'll just multiply x with this x and x square with this x. So I will get x cube, then I don't need to worry about all the other terms. So with this I can tell that the equation which we will get will be of third degree equation. The degree of the highest order, or degree of the x is 3 here, and we have 3 roots. So number of degree equal to number of roots, number of highest degree of variable. So this is just for 2 root equation. Here you can see it is for 3. We'll get, in this case we'll get 3 roots, and in this case we will get only 2 roots. This is the negative 2 and negative 3 is the root here. And now that we have multiplied 2 factors together, we'll take the result, and so we'll take the result and multiply it by third factor. Again we'll use a box to organize the multiplication, because it can get confusing when identifying what we have and haven't multiplied. When we multiply we get like terms in this case. So here we basically are multiplying, we are using the same equation as above, x squared minus 5x plus 6. Yeah, so this is the equation for this one. So for this whole term, the equation will we get x cube minus 4x square plus x plus 6. So as I told you, the highest degree of this is 3. I also got 3, and the number of roots will be 3 as well. Let us write a polynomial equation which has roots 2, 2 and negative 3. So for an equation that has root 2, and so the roots are 2, 2 and negative of 3. So the equation will be x minus 2, x minus 2 and x plus 3 will be equal to 0. Then what I can do, this I can write it as x minus 2 whole square, x plus 3 equals to 0. I can use the identity a minus b whole square equals to a square plus b square minus 2ab. I can write this as x square plus 4 minus 4x, and I can write x plus 3 equals to 0. Now I'll multiply this with first I'll multiply this part with x, then I'll multiply this part with 3. So it will be x cube, this will be x cube, and this will be plus 4x minus 4x square plus 3x square plus 3 4 is 12 minus 12x equals to 0. So I'll combine the like terms. So x square, and this will be negative of x square, then 4, so this will be negative of 8x, and in the case of a constant we just have I think 12. So we are done with this, done. This equals to 0. Let us see the equation they have got. They haven't solved the equation yet. Okay, yeah, so more examples on polynomial equation. So basically the equation for x equal to 2, 2 and negative of 3, we get the equation as x cube minus x square minus 8x plus 12. My addition and subtraction is correct, I think. Yeah, everything looks nice. Yeah, so as we can see, the highest order, no, see, highest degree is 3, and we have here 3 roots. Then what do we have? We have more examples of polynomial equation. In the following equations, students will construct polynomials with given roots. The polynomials will be constructed both from explicitly given roots and from the graph. Write an equation for polynomials with roots 2 and negative 5. We can do that. We'll just write x minus 2 and x plus 5 equals to 0. We'll multiply this and we'll get the equation. Write equation for roots with 1 1 negative 1 negative 1. The y-intercept of polynomial is the point on the graph that touches y-axis. Okay, the y coordinate of the y-intercept can be found by substituting x equals to 0 into the polynomial equation. Write an equation for polynomial with roots 2, 2 and negative 3 with y-intercept 4. This is a condition given here. So, and use the graph of polynomial below to write the equation of polynomial. Hint, use the roots where the graph hits x-axis and the y-intercept. When y equals to 0 in this condition, so yep, we can find like this. Instead of writing this 0, I can write this as y in the form of an equation. Then we have y equals to x square. This will be x square and this will be 5 minus 2. This will be plus 3x and this will be minus 10. Negative of 10 equals to y, and yep, I get the same equation. For this one we can do the x minus 1 whole square and we multiply it by x plus 1 whole square, or we can also write this as a minus b into a plus b. That will be a square minus b square, and that will be pretty much easier. So I'll just write y equals to x minus 1, x minus 1, x plus 1, x plus 1. I'll use the identity a plus b into a minus b equals to a square minus b square. Yep, that was the identity, I think. And then I'll club x minus 1 and x plus 1. So I'll just write x square minus 1 multiplied by x square minus 1 equals to y. Then y equals to x square minus 1 whole square. Then this can be written as x power 4 plus 1 minus 2 into x square. X power 4 minus 2x square plus 1. Correct. Then again we have few examples. The solution seems to be correct. Solution is correct. This was question number 5, I think. Yep. So we'll go to question number 6. Question number 6, square root of 30. We need to find square root of 30. So there are a lot of ways to find the square root. One is radical method to, so we just simplify in the we just write it in a simpler manner, and we just constantly divide this and find for the a pair of the terms so that we can form a square and we can take that number out of the square root. So for example, if for root 30, I can write root 30 as 3 into 10. 10 will be 5 into 2. So we cannot form pair of numbers. So we'll be going with a different approach. So root 30 lies between root 30 lies between root 25 and root 36. Root 25 is 5 and root 36 is 6. So the square root of 30 should be between 5 and 6. So what I will do, I will first take 30 and I will divide with this 5, the lowest number. I will get 6 here. Then I will add 5 and 6. So the last number with the number I have obtained. So I will just add 5 plus 6 and I'll take the average of this. It will be 5.5. Now 5.5, if I just multiply 5.5 with 5.5, if I take the square of 5.5, then 5.5 square is 30.25. So it is again not equal to 30. So what I can do, I will take 5.5 and I will take the again this 5. No, I will just take divide 530 with 5.5. So 30 divided by 5.5 will give me 5.45. Now I will take the average of these two terms. So 5.5 plus 5.45 divided by 2 will get plus 5.5 divided by 2, we get 5.477. So we'll get 5.477. Now we'll take the square of this number and we'll see. So square of 5.477 is equal to 5.477 square, 30.0005. So we can take this approximation or we can just do this averaging once more. So we can just multiply, we can just divide with 5.477 and whatever number we get. So 30 divided by 5.477, we get 5.4774. This is pretty accurate, 5.4774, and then we can take the average of this, and again we'll get 5.4772. Okay, so yep, here also under square root of 30 is 5.477. Here the solution is given till solution is having some sort of error. This 30 minus 25 equals to 5. Square root of 35, then we have square root of 30 is between 5 and 6. Okay, 30 minus 25 is 5. 36 minus 30, I don't know what kind of mathematics is this. 36 minus 30 is 11. Then 5 plus 5 by 11, this number should be 25. I think this number should be 25, but the final answer seems to be pretty close. Let's see what is the square root of 5.45. What is the square of 5.45? It is 29.7025. In this case, we can write this as solution is having some error and 36 minus 30 is not equal to 11. A better method is to divide 30 by 5, which is equal to 5 point 30 by 5, which is equals to 6. Take average of 6 and 5, which is equals to 5.5. Divide 5.5 with by 30. Divide 30 by 5.5. 5.5, which is equal to 5.45. Take average of 5.45 and 5.5, which will equal to 5.477. This is the correct method, and we get pretty accurate answer. So the solution is having some error, and 36 minus 30 is not equal to 11. A better method is to divide, is 30 divided by 5 equals to 6. Take average of 6 and 5 equal to 5.5. Divide 30 by 5.5 equal to 5.45. Take average of 5.45 and 5.5, which is equal to 5.477. This is the correct method, and we get pretty accurate answer. This solution is incorrect. This was question number 6. So we'll go for question number 7. We need to draw the graph. So we need to draw the graph of ln of log natural of x. Graph this. So how the solution is given here. So graphing ln of x, to find function f of x is a logarithmic function with base e, which is an irrational number with value is equals to 2.71828. Rounded to 5 decimal places, it is called the natural logarithm and is originally in the form of log base ex. So yeah, correct. So ln of x is originally written as log base e of x, but we don't write this as log base e of x. So for this, we'll say y equals to ln of x. Then we'll find the value of so here it is putting some random numbers. So we'll find the value of y for x equals to 2.7. First it will be 0. For x equals to 1, for x equals to 2.7, for x equals to 7.4, x equals to 20.1. So when I write when I put x equals to 1, I will get ln of 1 is basically 0. I knew that. Then ln of log natural of 2.7, it is 0.99, so I can write it as 1. Then log natural of 7.4 is 2.001. Can write this as 2. Then ln of ln of 20.1, it is 3 point, ln of 20.1 is 3.0007, write it as 3. So how we chose 2.7, 7.4, 20.1? The basic idea is we cannot just we cannot just imagine 2.7 for x or 7.4. These values are obtained by taking the anti-log. So if I take anti-log, I'll get e power y equals to x. Then for y, I will put 1, 2, 3. So for e power 0, I will get 1. For e power say 1, I will get 2.71. For e power 2, I will get what is e square? E power 2, I will get 7.38. So again 7.38. For EQ, I will get 20.085. So in this way we obtain the value for x, but we have done the opposite here. Now we have the value for x and we have the value for y. We'll draw the axis and I'll draw it better. Now I will use the red color. So we have for x, for x we have 1, 2.7, 7.4 and 20.1. Let's say this is 1, then this is 2, then 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and this, let's say this is 20. 20.1 will lie here. And for y we have 0, 1, 2, 3. So this is 0, this is 1, this is 2, this is 3. So our first coordinate is 1, 0. So x is 1 and y is 0. So this is my first coordinate. Second coordinate is 2.7, 1. Y is 1 and this will be 2.7. Third is 7, 7.4 and 2. So 1, 2, 3, 4, 5, 6, 7. 7.4 and here we have 2, and fourth one is 20.1. This was 20.1 and we have 3. Now we will just connect these lines. This will go to up to infinity. Where is the cursor? Yeah, so in this way we draw the curve for, or we graph ln of x. So coordinates are correct solution. Now I think this will be 8th question. Yep, this will be 8th question. What is an isosceles triangle? Isosceles triangle. So an isosceles triangle is a triangle having two congruent or equal sides. Correct. It is a triangle which has two equal sides. So this is a triangle ABC. So here, if AB is equal to AC, or if AB is equal to BC, or if BC equals to AC, then it is an isosceles triangle. And if AB is equals to AC, then angle made at B will be equal to angle made at C. And if AB equals to AB equal to BC, then angle made at C and angle made at A will be equal. And if BC equal to AC, then angle made at B and angle made at A will be equal. So here we will be having angle at B will be equal to angle at C. In this case, we'll have angle at AP and BC. So angle at C and angle at A. Angle at C and angle at A, and for this case we'll have angle at BC equal to AC, so angle at B, angle at A. Yeah, so this is an isosceles triangle with two equal sides. Though they can be any equal sides, but the sides should be equal, and equal sides make same angle with the base. So I can also give an example. So let's say this is a right angle triangle. This is 90 degree, then the sum of triangles is 180. So this will be 45 and this will be 45 if ABC, if AB equals to BC, then the angle will be angle at P equals to angle at C, which is equals to 45, and total sum of all the angles is 180. 90 plus 45 plus 45, which is 180. So this is correct solution. Great job. Then we have ninth question. Question number 9. How to compute for a cofactor matrix. Now this is going to be a lengthy solution. So have you ever used blinders? So if blinders prevent you from seeing the side and force you to focus on what's in front of you. A cofactor is a number you get when you remove the column and row of the designated element in a matrix, which is just a numerical grid in the form of a rectangle or a square. The cofactor is always preceded with a positive or negative sign depending on whether the element is positive or negative. So in this case, it is calculating the cofactor of this matrix. 3, 5, 6, 7, 2, 8, 4, 1, 9. Now, for calculating the sign of cofactor, we have a rule. I'll just write it with blue color. So Aij is the cofactor. Aij is the cofactor of the element. In the place of I, we'll write the row number, and in the place of J, I is row, J is column. We will have negative of 1, I plus J. Then we have determinant of minor of Ij. So if you ever forget the sign of the position, you can just calculate using this method. Basically, for calculating the sign, we just need this part, and this is the cofactor. So this is the formula for calculating cofactor. What is minor? I'll just tell you. So suppose if we want to calculate cofactor for 3, then we'll block the row, then we'll block the column, third column, and we'll block this third row. Then we'll block the first column and first row. So we block the row and column in which that number is lying. So this number is lying in first column, first row is blocked, and this number is lying in the first row, then first row is blocked. Then what we do, we get a matrix of, so I'll just undo this. Yep. So for cofactor of 3, we get the matrix of 2, 8, 1, 9, and then we find the determinant of this matrix. So this matrix is called minor, Mij. So this is not Mij, this is basically M11, minor for first, because my I and J is equals to 1. So this is the Mij, and for calculating the cofactor, I will just take the determinant. So this will be 2 into 9, 18 minus 8. This will be 10. Determinant of so determinant of, or instead of this I can just write with the sign equal to 10. So we get this 10, and again we are going to calculate for the cofactor for 5. So for 5 lies in the second column and first row. So I will get the matrix of 7, 8, 4, 9. So my minor will be 7, 8, 4, 9. My minor for 5, minor is 7, 8, 4, 9, and determinant of this will give to 7 into 9, which will be 63. So 63 minus this will be 24, will be 39. Let us check cofactor 2819 10. Then 7849 we get 31 63. Okay. So I did a mistake. It will be 63 minus of 32. That will be this will be 31. Then again we will be calculating for cofactor of 6. So for cofactor of 6 I'll block this row and this column. So my minor matrix will be 7, 2, 4, 1. So for 6, minor matrix is 7, 2, 4, 1. Determinant of which this will be 7, 1 to 7 minus 4 to the 8. This will be negative of 1. Then again we calculate for 7. So for 7 we will block the second row and first column. So my minor will be 5, 6, 1, 9. For 7, 5, 6, 1, 9. Determinant will be 5, 9 to 45. This will be 39. For 2, I will block this and this. So 3, 6, 4, 9. 3, 6, 4, 9. Determinant of this will be 3, 9 to 27 minus 24. 27 minus 24 will be 3. Then we again go for 8. For 8, this one and this one will be blocked. So 3, 5, 4, 1. 3, 5, 4, 1. Determinant of this will be 3 minus 20. This will be minus of 17. Then for last one, for 4, We have 5, 6, 2, 8, 2, 8, 5, 8 is 40 minus 2, 6, 12, 28. Then for 1, we have, for 1 this will be blocked and this will be, so 3, 6, 7, 8, 7, 8. Determinant will be 3, 8, 24 minus 6 into 7. This will give us minus of 18. Then for last we have 9. For 9 we will be having 3, 5, 7, 2. So determinant of 3, 5, 7, 2, 3, 2 is 6 minus 7, 5 is 35. So this will be 29, I think. 35 minus 6, 35 minus 6, yeah, 25, 29. So we will be writing the cofactor matrix. First, we'll write all these terms. First, we'll just create the matrix. So we'll start with the first number. We have 10. So 10 was the cofactor of 3. So 10 will be written in the place of 3. Then for 5 we have 31. So it will be written in the place of 5. Then for 6 we had negative of 1. Then for 7 we had 39. For 2 we had 3. Then negative of 7. Then we have 28, negative of 18, and 29. Now we are going to change the sign. So we have calculated just this part only. Now we have to correct the sign as well. So for correcting the sign, either we can use this one, this thing, this sign matrix, or we can just manually calculate. Like if we forget the sign for a particular position, we can just manually calculate. So for 3, I was 1 and j was 1, so minus 1 power 2 will be plus 1. So this will have plus sign. This will have, the sum of I plus j will be odd in this case, so this will have a negative sign. And this will, for some, for in this case the sum will be positive. 2, this will be, I will be 1 and j will be 3. So yeah, the sum will be positive, so we'll have, we do not change the sign here. In this case we change the sign, just write the minus. Here we change the sign, we add minus, so here I'll just plus it, and 28, and again I will change the sign here, and 29. So the cofactor matrix is not given for this one, but so cofactor of 7 was 39. Okay, so yeah, this solution looks pretty correct. Correct solution. Great job. Solution is correct. Now we will move for another question. This is question number 10. Tangent of 30 degree. So we need to calculate tangent of 30 degree. So how this has done? For sine function, to determine the value of tangent of 30, we must memorize some values of sine and cosine with angles that are multiple of 30 and 45. So this is not really hard since there is a pattern that we can observe. For sine function, sine 0 is 0, sine 30 is half, sine 45 is root 2 by 2, basically it is 1 by root 2, sine 60 is root 3 by 2, and sine 90 is 1. We see the pattern for sine. We just need to take the square root of 0, 1, 2, 3, 4 and divide it with by root 2 as the angle increases. For cosine, it is very simple. We just need to take the square root of 4, 3, 2, 1, 0 and divide it by 2. So if it is, this is for 0, then this is for 1. So I can suppose if I write sine 30 as 1 and divide it by 2, root 2 as angle increases. I will divide it by 2. For cosine 30 degree, I will take the second value 3 and divide it by 2 as angle increases. So for 4 it is dividing by 2. For 3 it will be we take the square root, and here we have 2 for 4 and 2 for 2. Here also I should be adding 2 because it is the second number. So I will get 1 by 2 and root 3 by 2, which are the correct values for sine 30 and cosine 30, and tangent of 30 degree will be sine of 30 degree over cosine of 30 degree. So it will be 1 by 2 over root 3 by 2. This gets cancelled and it will be 1 by root 3. So yep, the solution is correct. If I just multiply, get root 3 by 3. Okay, the solution is correct for this case also. So correct solution. Great job. Solution is correct. So this is all for this session. So if you like this Q&A session, hit the bell icon and subscribe button so that next time you get a notification when I'm going to be live for this for on OneClass, and you will be notified for all other Q&A sessions. And if you need any tutoring help or if you need any one-to-one class help, you can check the links in the description below. And also, if you would like to submit your questions or if you need any homework help also, you can check the same links below in the description. So that is all for today. Hope to see you soon in my next video. So bye bye.